Alright, so today we're going to talk about how to calculate an empirical formula and talk about what an empirical formula really is. So an empirical formula is the smallest whole number ratio of a compound. So basically, what does that mean? Well, let's look at a compound. Let's look at C6H12O2. O2, okay. So if I'm looking at this compound right here, this cannot be an empirical formula because it should be the smallest whole number ratio of a compound. And right here, I can reduce this, just like a fraction, basically. There I've got 6, 12, and 2. I can divide all of these numbers by 2 and get a smaller whole number ratio. So right here, if I wanted the empirical formula, it's CH2O. That's my empirical formula because it shows me my smallest whole number ratio. This is the molecular formula, which we're going to talk about later. But basically, that's the actual number of atoms. This doesn't show you the actual number of atoms. It just shows you the ratio or the percentage of each compound, or each element in the compound. So this right here, if you see this, you might think, oh, wow, this is going to be really easy. It's not always as simple because I don't always give you this formula. So normally when you calculate the empirical formula, you're going to follow these steps. You're going to go percent to mass, mass to mole, divide by small, times to whole. So what does all that mean? The first step is you're going to figure out the number of grams. Of each element. Okay. Usually I'll give you a percentage of each element, and really the percentage is the same thing as the number of grams, because if you assume you have 100 grams, that would be the amount of grams you have, which I'm going to show you that, so don't worry. Then you're going to go mass to mole. So convert to moles. So take all of your numbers of grams and convert them to moles. Then you're going to divide by small. So you're going to divide all numbers of moles by smallest amount of moles. So once you find your number of moles, you're going to take the smallest amount of moles and divide each of those numbers by that smallest number. Okay, times to whole. Okay, so if you get a number like 0.5, 0.33, 0.66, those are not whole numbers. You need to multiply by either by 2, 3, or 4 till you get whole numbers. If they're already whole, leave them alone. Okay, so let's go ahead and do an example. That's the best way to see what all this means. Okay, so find the empirical formula for a sample of 25.9% nitrogen and 74.1% oxygen. So the first step is percent to mass. So I give you a percentage. You're going to have to take this and make this number of grams. But like I said, if you are given percentages, assume you have 100 grams. Then that really means that 25.9% is 25.9 grams. So 74.1% is 74.1 grams. This is the easiest step, basically. Okay, so nitrogen. I have 25.9 grams. Okay, assume you have 100, so that's just the same thing as grams. Oxygen, I have 74.1 grams. Okay, so the next step, mass to mole. So now I'm going to calculate my number of moles. So with your periodic table, let's go ahead and figure this out. Grams will go on the bottom, moles will go on the top. 1 mole is equal to so many grams, and that's got to be my molar mass. So nitrogen's molar mass is 14.01. Okay, so let's go ahead and calculate that. So with your calculator, 25.9 divided by 14.01. Okay, and it's going to give me 1.8486. I know it seems like a lot of decimal places, but really you don't want to round these too much because that will mess up your calculations. Okay, so now let's do oxygen. Oh, it's a naked number. Okay. Now we're going to calculate this. We're going to go to moles. So the molar mass of oxygen is 16. So 74.1 divided by 16 gives me 4.63125 moles. Okay, so now I've got my moles. The next step says divide by small. So of these two numbers right here, which one is the smallest? It's going to be 1.8486. That's my smallest number, so I'm going to go ahead and divide both of these numbers by 1.8486. Divide both of them. Okay, so this is going to be 1. So let's do the other number, 4.63125 divided by 1.8486. All right, I got 2.5. Okay, so if I had just gotten whole numbers, these would be my subscripts. So if I had whole numbers, it would be N, that number, O, that number, and then it would be done. But I don't have whole numbers, I have to times till whole. So I am either going to multiply by 2, 3, or 4 to give me whole numbers. Well, when I have 0.5, what number will give me whole numbers? So 2.5 times 4 won't give me a whole number, or well, it will, but it won't give me. It'll give me a smaller or a bigger number. 3 will definitely not give me a whole number, but if I multiply it by 2, it will give me a whole number. So let's go ahead and do that. Let's multiply both of these numbers by 2. Okay, so now N has 1 times 2 atoms. Okay, the next part, oxygen, 2.5 times 2 will give me 5. This is my empirical formula. So really you're trying to figure out what the subscripts are, and you follow this process to get the subscripts. Okay, so let's do another one. Alright, so what is the empirical formula when you have 6.256 grams of carbon, 1.392 grams of hydrogen, and 8.352 grams of oxygen? Alright, my first step is go from percent to mass. And some of you will probably say, well, I don't have a percentage. That's okay. You have a mass. It says go to mass. So you're done. You don't have to do that first step because you already have your number of grams. Okay, so for carbon, I have 6.256 grams. For hydrogen, I have 1.392 grams. Do not round these, please. And oxygen, I have 8.352 grams. Okay, my next step, my first step was percent to mass. My next step is mass to moles. So I'm going to convert all of these to moles. Okay, so moles will go on top. 1 mole is equal to 12.01 grams. I got that number from the periodic table, which you should have out. So 6.256 divided by 12.01 gives me 0.52089. Do not round these yet. So now let's go ahead and convert hydrogen to moles. Hydrogen's 1.0. Okay, so I'm going to go ahead and take 1.392 divided by 1.008. That gives me 1.38095 moles. All right, let's convert oxygen now. It's 1 mole divided by 16 grams. All these numbers I got from the periodic table. 8.352 divided by 16. Give me about 5.52. Okay. All right, so of these numbers, which one is the smallest? Well, technically it's the carbon. Oxygen's pretty close, but let's just go ahead and divide it by this one. 52089. Divide everything by that. 52089 again. All right, so this one should be 1. Okay, so 1.38 divided by, and make sure you're not rounding here, divided by 0.52089. Okay, we get 2.66. Okay, so the next one, it should be really close to 1, so I'm probably going to round this one. It is, it's 1.00, so we're just going to say this is 1, which is fine. Okay, so now we've divided. Okay, so when we go and look at our numbers, we got 1, 2.66, and 1. And now you're probably asking, okay, what do I do now? So the next step is to times till whole. So I want you to write this down somewhere. Okay, if you get a number that ends in 0.5, you're going to multiply it by 2. If you get a number that ends in 0.33 or 0.66, multiply it by 3. If you get a number that ends in 0.25, multiply it by 4. Okay, so our number is 2.66, so we're going to multiply everything by 3. Everything gets multiplied by 3. Okay, so carbon should be 3. Hydrogen should be 2.66 times 3, which gives me 7.98, so it's 8. And then oxygen is also 3. This is my empirical formula. If you just follow these steps each time and you're not rounding a whole bunch, try to keep as many figures at the end as possible, so like 4 to 5, then you should have no problem doing this. All right, I will see you in class so we can do some practice problems.